Hello everybody, I'm Xavier Ortiz and I will be presenting the project Process and Quality Improvements in a Nano Brewery. The project took place in a Nano Brewery named Ingeniero Microbrewery. This company began taking its shape at the beginning of 2011 and started operating late in 2013. It is located in the urban center of the town of Manatee and produces 21 gallons of beer per week. They produce beers of the ale type, which include porters, IPAs, and wheat beers. The current process for brewing was one that employed malt extract as raw ingredient. The main problem the brewery was facing is that the resulting product presented inconsistencies in many of the final characteristics, resulting in lower quality in their offer to the customer. The factors were color, alcohol content, and body of the beer. All these characteristics had to be within certain range in order to comply with the National Beer Style Guidelines and to satisfy the palate of the market sector composed of craft beer knowledgeable customers. The proposed solution was the conversion of the brewing process from extract to all grain. This conversion had the advantages of providing lower cost of materials, but it required an initial capital investment for equipment, besides being more labor and time intensive. The schedule was designed on a weekly basis. It went from installing the equipment through operations and data collection, all the way ending up in the analysis of the data compiled and the compilation of results. The all grain equipment was installed along with the hood for room temperature control. The cost of all this equipment was added to the amount invested for the rate of return analysis. The equipment was then tested for heat production capabilities. After testing the equipment, the beer wort, which is a precursor of beer, was produced and analyzed. Initial density was determined and the characteristics regarding the visual appearance were annotated. The values obtained from the analysis were tabulated in order to be compared. At first glance, the oak grain process seems to be more consistent. These values were later studied for variability determination for all three beer styles. The wort was oxygenated and mixed with the active yeast. It underwent fermentation for a couple of weeks. After this period, it was safe to assume that the yeast had converted all the available sugars into alcohol. Samples were taken to assess the final conditions. All the steps regarding the production of wort and involving cleaning and handling of equipment were annotated in an operations journal. These notes, along with the manufacturer's recommendations and equipment guides, were used to build a comprehensive maintenance schedule. Both the economic analysis and the quality assessments were performed. A simple comparison of ingredient cost was made between the extract and all grain methods. The extract was found to be a more expensive sugar source than the grain themselves. Then, the feasibility of the investments was assessed by determining the capital recovery. The annual income to generate a 10% rate of return required for the production to be increased in 53%, taking into account the savings achieved by only changing the process. The benefit cost analysis resulted in a ratio of 3.20, which clearly justifies the project from the economic perspective. The values obtained from the analysis were used to construct parameter distributions. The distribution for the all grain process, seen here as a dashed curve, shows an average pattern around the optimal value than that of the extract process. This indicates that the proposed process exhibits less variability than the current method. The pattern repeated itself for all the beer styles on both initial and final density analysis, confirming the initial observations of the all grain process being more consistent than the extract process. The measurements were then used to generate capability reports. All capability indexes regarding the extract process, seen on the top chart, were below 1, varying from 0.354 to 0.677. In the case of the all grain brewing method, displayed on the bottom, the values range from 1.23 to 1.36. The fact that all the values surpass 1 means that the proposed process is capable of producing the product with parameters within the acceptable range and around the target values. The Standard Operating Procedures book was developed following all the process steps and the notes from the brewer. The book was assessed for detailed content by having personnel that were not familiarized with brewing to run the process while time was being measured. All the steps were taken according to specifications and the time was never exceeded except for just one occasion when the time limit was surpassed by only 9%. Maintenance standards were written with specific instructions on when and how the equipment needs to be serviced. To ensure that the equipment will last as specified by manufacturer, the standards recommended were exceeded by taking measures such as increasing the frequency of checkups and equipment cleaning. The project proposed of changing the manufacturing process in a Nano brewery in order to increase quality and reduce costs was successful. Transforming the process from extract to all grain results in greater consistency in product and parameters such as density and alcohol content. The change can also achieve a reduction in costs of raw materials, providing the brewery with the capability of expanding productions later on. This ends this project presentation. If you have any questions or doubts or want more information about this project, I can be contacted at the email provided or on the platform of the course. Thank you for your time and your attention.